Hello, Augies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today's question is from Steve Felkner. He is at KE5SF. He has an Ameritron AL6 606 amplifier, which is a 600 watt amplifier. And he has a Yaesu FT991A radio, which is set at 10 watts RF power output. Says, now when I transmit on 20 meters or 40 meters, the meter on the amplifier shows I'm only putting out about 250 watts. I'm a little surprised, actually. So my question is, why am I only putting out 250 watts? Shouldn't I be putting out at least 500 watts? Thank you. I really look forward to reading your answer. Okay, let's think about this. Your radio, the 991A, will put out 100 watts, a full 100 watts. And you can turn that down if you want. Now, that signal that goes out goes into the amplifier. Where does it go from there? Well, it's not reflected back. The input impedance on that amplifier is 50 ohms. So all the energy that you put in goes somewhere. And where it goes, I'm going to tell you a dirty little secret about amplifiers, that a lot of the stuff you've learned about electronics is about to go out the window. So let's take a look. I believe that your 606 is all transistors. I'm going to pretend it has one great big tube in it. Here is the triode. Okay, here is the cathode. Okay, and here is the plate. Very simple. Triode. Been around for over 100 years. Here's your FT991A. A is the one with the good spectrum scope on it. Here's your output. Okay, here's your positive. Here's your ground, the positive. This essentially, I mean, there's a little impedance matching in here, but it comes straight into there. Now, what happens? In order to drive this tube to get up to 600 watts, there has to be a period of time when there is current flowing. We'll take electron flow. Electrons are going to flow from the cathode up to the grid. Okay, which means current, which is positive, electrons are negative. Current goes in and out the cathode. Okay, in the meantime, we're going to make this positive here. Normally in a standard class A amplifier, the grid is always negative, but you've got electrons coming up here, and to get enough electrons to come up to here to do anything serious, you have to take the grid seriously positive. That means there's going to be a current flow. In other words, the FT991 is taking its 100 watts and it is dissipating it in the tube. Okay? At the same time that this thing is creating your 600 watt signal. Now, this is a linear amplifier, but it's also a power amplifier. It's not multiplying voltage, it's multiplying power, which is both voltage and current, okay? And they are being dissipated in here. Now, being a linear amplifier, to get 600 watts out, you have to put in some certain amount. Now, I happen to have the ALS 500M. In order to drive this to the full power output, I have to put 62, yes, I measured this, 62 watts out, because the process of amplification, and it's also transistor, we'll switch to transistors in a minute, but 62 watts. Now, if I were to drop, this is the actual drive I need. If I were to drop that to 31 watts, what happens to the output? It's no longer 500 watts, it's now 250 watts. Remember, linear. So if this goes and doubles up to the max, this is the max voltage you're supposed to put into the thing, it'll double the output. So if you're only putting in 15 watts, it'll drop it by half again, 125 watts out. Let's do this with transistors. You've got the control here, you've got the drain up here and the source down here, and this is the gate. Now, often these will have multiple FETs. Okay, my ALS 500M has 4 of them, and this grid just goes all the way, not grid, gate goes all the way through. Okay, so where's it going to go? Okay, you've got current coming this way, RF current. It's going to go down here, and it's going to affect what's coming down here. The only way to get sufficient amplification is you need power to come in. Power. This amplifier is going to use the power from the rig to drive this. This is, instead of voltage for tubes or current for transistors, we're going to use the multiplying the two of them into power. So these FETs are called power FETs. And they ain't dinky little things either. They're humongous. They're very big. I mean, they're like that. Okay? They're like that. Big old things. And they've got heat sinks on them. Now, what's happening in your case, I don't know how many watts you have to put into your amplifier to get the full watts out. Let's just say it's 50. Okay? You need 50 watts from your radio. I know it's capable of 100. But 50 watts out drives an hypothetical amplifier to 600 watts. Okay? Now, if you go above 50 watts, all you're doing is putting more heat into this thing. You're not getting anything more out. So if you were to put this into a dummy load with a watt meter and gradually turn up the drive on your amplifier in CW mode with the key down, you would find there would be a point where this power did not go up anymore. That is the maximum drive for your amplifier. Okay? Now, if you did 15 watts out of that, okay, that's quite a bit less. So what comes out the other side is going to be quite a bit less. I don't know. I'm not multiplying exactly here. Now, putting too much power into this creates a lot of heat that's got to be dealt with, plus it can lead to distortion. So there is a wire running from your amplifier back to your radio, and it's labeled ALC, automatic level control. So if you put in 100 watts, this signal, it happens to be negative going, and it goes like 0 to 4 volts on 0 to minus 4 volts on modern amplifiers. It can be higher on other amplifiers. But what this thing does is it turns down the transmitter power. Okay, so what's going on here is you put in 100 watts, this thing is immediately going to tell this thing to back off to 50 watts. And you can try increasing the power past 50 watts, but it won't increase what comes out of here. And this thing will continue banging on this thing and not let you go above 50 watts. Okay, almost all power amplifiers have this ALC control. As it turns out, my ALS 500 does not have this. So I had to go in and very carefully figured out what would give me the maximum power out, and it turned out to be 62 watts. So if I'm going to operate this amplifier, I have to manually turn the power down. So I go in, and here is the rig. I push my multi-knob. There's RF power, okay? And I just crank it down to 62 watts, right there, okay? That gives me the full power out, but I'm not wasting power as heat in there, and I'm not damaging the thing by doing too much, okay? So that's what happens if you don't have the ALC. And in your case, you should go through this exercise of gradually increasing the power with your power meter and with your dummy load to see how much drive it actually takes to get full power out. You'll find that it's less than 100 watts, okay? And that's what the ALC is for, is to protect the amplifier and keep it from putting too much power in there. So what we've seen here is most power amplifiers take less than 100 watts to go to maximum output, okay? And there is a cable that connects from your amplifier to your radio. The radios have all got this input, ALC. And you plug it in there, it's a little phono connector, RCA jack, okay? And you hook that in there, and the amplifier will tell your radio to back off, buddy. I don't want to get so much. And the radio will very docilely obey the command from its big brother, the amplifier, and give it just enough to carry the thing all the way to max power. Now, the reason for the ALC is if you're doing sideband, your voice might get softer, which would cause the amplifier, maybe it could do a little bit more output. But these are designed as linear amplifiers. That means if you drop the power out will drop. So before you do all these exercises with your power amplifier, you want to check your mic gain settings and set them exactly according to the instructions in the instruction manual, and your compression settings. Now, why your compression settings? Well, you've added 600 watts in there because you obviously want to get through. Well, one of the best ways to get through is to put a little bit of compression on top of that signal. Again, adjust it exactly as it shows in your manual for the radio. The radio, not the amplifier. Now, here's the deal. The duty cycle of single sideband is about 20%, but if you get your compression set properly, the duty cycle goes up to about 40%. And what that means is you get about 3 dB more punch than your signal going out, even though the power levels are set to the same. Have you ever noticed while watching TV that the commercials sound louder than the regular program? Well, if you look at the volume meter, they're the same. But the commercials have had their audio compressed, so it'll sound twice as loud as the regular program does without breaking any of the FCC limits in there. That's where that comes from. Now, you can do the same kind of thing here. You've got 600 watts, but you can double its capacity to carry information by 3 dB by using compression properly. If you compress too much, you create distortion, and that linear amplifier of yours will faithfully send that distortion on out, and you don't want that because that distortion makes it harder for the DX to understand you. Okay? So there you go. A lot of information in this video about setting up amplifiers, about the ALC, about setting up your mic gain and your compression. Of course, you can help get good communication by speaking distinctly with proper enunciation. That's a long word. I'm not even sure that's in the index to the radio handbook. But enunciate properly, don't speak too quickly, and so on. And you'll have, that's all different kinds of stuff to make DX work better. There you have it. So Steve, back to you. Until we next meet, 73.